Hello, my fellow chemists. In this video, we're going to take a look at some advanced density problems, and we're also going to take a look at the concept of using water displacement to determine the volume of solid objects. And that is a concept that's used fairly often in some of the more advanced density problems. This video is labeled as an intermediate level video because it assumes that you already have some basic understanding of the concepts of density, you understand its formula, you know how to manipulate its formula to solve for mass and to solve for volume. If you need to review those concepts, I will put a link in the upper right hand corner. So let's get into this video here. So I have up here that volume determination by water displacement. What that means is if you submerge a solid object in water, the volume that the water increases is equal to the volume of the solid object. If you need to determine the volume of a solid object to determine its density, it is often rather tedious if you're going to be doing it by calculation. So a simple way that chemists use to find the volume of a solid object is to simply submerge it into water. So if you have a graduated cylinder, and a graduated cylinder is just a long, relatively thin piece of glassware, and it's calibrated going all the way up. And if you were to add some water into that, let's say this water's initial level is 50 milliliters. And then you were to take some type of a solid object and you were to place that solid object into the water. What's going to happen is the overall level of the water will increase. And the amount that the water increases is equal to the volume of the solid object. And this is often much easier to find volume of solid objects like this than by doing a calculation. So let's say you place the solid object in the graduated cylinder and the water level increased from 50 to 62 milliliters. Well, 50 milliliters is the volume of the water, and 62 milliliters is the volume of the water plus the object. So if you want to find the volume of just the object, take the 62 milliliters and subtract the 50 milliliters, and the volume of the solid object would then be 12 milliliters. That is way easier than doing a multitude of calculations on that object to try to figure out what its volume is. So in the problems that we're going to look at today, they do incorporate using water displacement to determine the volume of a solid object. So let's take a look at these two problems, and as we do, we'll keep in mind that volume displacement is being used for, or water displacement is being used to determine the volume of these objects. So the first problem says, if a 63-gram metal sphere is placed into a graduated cylinder that has an internal water or initial water volume of 72 milliliters, and the sphere causes the water level to rise to 108 milliliters, what is the density of the sphere in grams per milliliter? All right, well, so let's write down what we know here. We know that density is equal to mass divided by volume. Let's see what information we're being given. Well, we're being given the mass of the metal sphere. Okay, so our mass is given. And we're being asked to find density of the sphere. So this is what we need to find. So we need to be also given the volume. Well, we are given the volume of the metal sphere, but we're being given it indirectly. We're being told that you have a graduated cylinder that initially has 72 milliliters of water in it. So if we see what that looks like, we have our graduated cylinder, and it has 72 milliliters of water in it. And then we were to place our metal sphere into the graduated cylinder. And after we do that, the water level increases. And it says that the water level increases from 72 milliliters up to 108 milliliters. And that's the water with the sphere in it. So if the 72 is the volume of the water, and the 108 is the volume of the water plus the object, if we subtract the 108 milliliters by 72 milliliters, we will get the volume of just the object, and that will be 36 milliliters. So now, in a roundabout way, we were given the volume of the object to be 36 milliliters. So now we know its mass is 63 grams. We know its volume is 36 milliliters. So now we just need to check our units. We're given grams for the mass, and we're given milliliters for the volume. Is that the units that we're being asked to find for, the answer in density? Well, it wants the density in grams per milliliter. So good, we don't have to worry about changing any of those units. So now that we have the terms, the mass and the volume, all we need to do is substitute them in. For the mass, we have 63 grams. And for our volume, we have 36 milliliters. And if we take 63 grams divided by 36 milliliters, we come up with 1.75. And the units will be grams per milliliter. Okay, so you can see how this problem uses the displacement of water to help figure out the volume of a solid object when looking for that object's density. So the next problem I have is going to be similar, where it still uses water displacement, but I want you to be very careful about listening to the wording of the problem, because the way these problems are worded will affect what you need to do to solve them. So I'm going to leave the work for this first problem up initially so that we can kind of go back and compare to that. But let's read the second problem and see if you can see how it differs from the first problem, because a lot of times when I give a problem like this to students, they'll try to solve the second problem the exact same way that we solved the first one, and they'll end up getting it wrong. So the second problem says, if the initial volume of water in a graduated cylinder was 62 milliliters, and a 1 pound object was placed in the graduated cylinder and caused the water level to increase by 23 milliliters, what is the density of the object in kilograms per milliliter? All right, well, let's see what information we're given, and then we're going to kind of compare and see how this problem is different from the previous one. So you have 62 milliliters. So we're being given the initial volume of the graduated cylinder, and then we're being told that it increases by 23 milliliters. This is different than the information that was given on the first problem. In the first problem, we were given, I'll bring it back up here again. In the first problem, we were given the initial volume of 72 milliliters. But instead of saying it increased by a certain amount, it told us what the new final volume was. So you have to be very careful in these problems to see, is it giving you the initial volume of the graduated cylinder and then the final volume of the graduated cylinder after an object was added? Or, like in this problem, does it give you the initial volume of the graduated cylinder and then tell you how much the volume increased by? So those are it's very subtle difference, but it's a very important difference in wording that you have to listen to because it does change how you have to solve the problem. So let's kind of go about and see how we would solve this problem here. And we'll do the same drawing with the graduated cylinder to kind of illustrate how it's going to work a little bit differently than the first problem. So for this one, again, we're measuring an object, and it says that the graduated cylinder initially had a volume of water in it of 62 milliliters. Okay, so it has an initial 62 milliliters, and that's just water. And then it's saying that it placed an object into that graduated cylinder. And when it placed that object in the graduated cylinder, it doesn't give us the final volume. The previous problem gave us the final volume. It told us what the volume was after you placed the object in. This one just says that it increased by, the volume increased by 23 milliliters. Well, if the volume increased by 23 milliliters, then that means 62 plus 23 is what the new final volume is. So that would be 85 milliliters. And the 85 milliliters is the water plus the object. But we didn't even really need to do that calculation because right in the problem it says it increased by 23 milliliters. Well, if you take 85 minus 62, which is the object and the water, minus the 62, which is just the water, that's where you get the 23 milliliters, and that's the object. So in this problem, by saying that the water level increased by 23 milliliters, they're indirectly telling you that is the volume of the object. Most of the students that I have, well, not most, but a lot of the students, they'll take 62 milliliters and they'll subtract 23 milliliters from it, and then they'll say that the difference between those two volumes is the object. No, it's not. They didn't carefully read the question. So the volume of the object is actually the 23 milliliters. So this 62 milliliters here is actually information that we don't even need to use in the problem. And this is one of the first times that we've seen that, but it's fairly often in chemistry problems where they will give you excess information that you do not need to use. So now we know that the volume of the object is equal to 23 milliliters. So our volume we're given, and that is 23 milliliters. And it tells us the mass of the object as well, and it says it's 1 pound. Okay, so we have the mass, we have the volume, and it does say what is the density. So this is a density problem. What is the density? But it specifically wants the density in kilograms per milliliter. All right, well, we have the milliliter, so we're fine with that, but our mass that we're given is in pounds. So the first thing that we have to do is convert the pounds into kilograms, and then we can use this density equation to finish the problem. So we'll take the 1 pound, and we'll set up our conversion factor. Put pounds on the bottom and kilograms on the top. If you remember, it's 2.2 pounds for every 1 kilogram. Pounds and pounds are set up to cancel out. And then we multiply across and we divide going up. So 1 times 1 equals 1, and then divided by 2.2 gives us 0.455 kilograms as the mass of our object in kilograms. So now we have our mass in kilograms and we have our volume in milliliters. So to find our density, all we have to do is take our mass of 0.455 kilograms and divide it by our volume of 23 milliliters. And when we do that, we will get a value of 0.0198, 0.0198, and the units on that are kilograms per milliliter. And that would be the density for this object. Hopefully you can see the difference between how we used water displacement in the second problem versus the first problem, because those are the two main ways that word problems will use water displacement to tell you the volume of a solid object. You have to be very careful with how you read the question to make sure that you are using the method properly. And just for fun, if we wanted to switch this final answer into scientific notation, it would be 1.98 times 10 and 1, 2. So to the negative 2 kilograms per milliliter. All right, that's it for the problems today. I hope you learned something, and in the next videos, we're going to begin to take a look at dosages and how dosages and densities can be mixed together to find properties of liquid medications. All right, I hope you learned something, and I'll see you in the next video.